Solving conditional trigonometric equations. We're going to find the exact value of the expression of tangent arc sine of negative square root of halves. And this here is got a notation error. So I'm just going to rewrite it. Tangent of arc sine negative three halves. Sorry about that. My computer's acting silly. So now that I have that, I'm going to work on it, but we're going to work on the parentheses first. When I see that arc sign, that tells me it's going to take the inverse of sine. And we need to figure out what is the exact value. And make sure your calculator is in degrees. This one here didn't tell you to be in degrees, but we want to be in degrees. The assignments will be real specific. So I want to make sure I'm in degrees mode in my calculator. And, you know, sometimes y'all are going to know what these values are anyways, because you know the unit circle by now. So that's great as well. But the sine inverse of the negative square root of 3 halves, if you go to the unit circle, or we look on here, we know we get a negative 60 degrees. Okay, so knowing that, I'm going to now say tangent, right? Now we know that value of negative 60 degrees. When we type that tangent of negative 60 degrees in your calculator, it gives me a negative square root 3, and that's my answer. Okay, let's do the next one. The next one says find the exact value without using your calculator or the table. So this here is wanting you to do it from memory. So we have arc cosine. So that means I'm going to take the cosine inverse of cosine negative 5 pi thirds, right? So what I need to do is figure out what is cosine of, and we've got to make sure you're in radians now on your calculator if you're using the calculator. Cosine of negative 5 pi thirds gives me a half. Awesome. That works out great. So now I can say, oh, now I want to take the inverse of that, and that gives me pi thirds. And that's my answer. Oops. Okay. So now let's go. My apologies. We're going to, let me clean this up. Let me scroll down a little bit. Or up. So we want to solve the next one. It says find all real value or all real numbers that satisfy the equation of the square root of 3 tangent x minus 1 equals 2. So what we need to do first is get tangent x by itself, and then get isolate x. So I'm going to add this one to both sides first. Now I have this. Since square root of 3 is, 2 plus 1 is 3. Square root of 3 is the coefficient on tangent. It's by multiplication. That means I'm going to divide both sides by that. So now I have tangent x is equal to 3 square root of 3. And then I'm going to take its inverse. So now I got x is equal to tangent inverse of 3 square root of 3. So I'm going to type in my calculator, round out to the nearest hundreds. Tangent inverse 3 over square root of 3. And I want to get the exact value, or not exact. Okay, if I go for the exact value, we get pi thirds. So exact value. Now, if I round and get approximation, I'm going to get, and I'm going to round to the nearest hundreds, 1.05. Okay, so I want to use the 1.05, or you could use the pi thirds. Okay, now this interval says that it can equal 0, and it's going to fall between 0 and 2 pi, and it can equal 2 pi. So let's solve for it. If I say 0 plus or minus that 1.05 or plus or minus pi thirds, we're just going to get that answer. So let's go with pi, right? Because, you got 2 pi here, you got 0, and you got pi. Let's go pi here. So if I said pi minus, you can say pi minus pi thirds, or you can plug in that 1 point. But if I say pi minus my pi thirds, it's going to give me, and you could have used without using the calculator with this. That's over 1 multiplied 3 over 3, which would have gave me 2 pi thirds. You could have done that. Now, if we wanted to do the exact value, well, now we could have said, well, we have 2.09. Skip this step. We could have said, oh, well, let's do pi and put it in exact numbers, which would have been decimals. It would have been really a long decimal. So if you want to use decimals, you can. Just be careful. But just make sure in the final answer, you answer it the way it's asked to be answered. So this is pi. And it stopped here on my calculator. Your calculator may round in another spot, minus that 1.05, which if I would have done the exact value, it wouldn't have done that stop it soon. Then I would have got 2.0915264. So, I mean, you could have used either or. I kind of like the exact values right here. Work with that and convert it to decimal if it asks me to. So now I'm going to take 2 pi minus that 2 pi thirds, or not 2 pi thirds, my apologies, pi thirds. So I'm getting my two values, right? I know here, I know I get these. This is my first set. This would be my next, these two here. One's exact and one's approximation, same with this. All right, now let's do the same here. I would say, oh, I need to have a common denominator, which is 3. So now I have 6 pi minus pi, which is 5 pi thirds. And if I wanted to put it in approximation, that would give me approximately, let's double check my math. 5 pi thirds gave me approximately 5.235987756. I want to check something. 2 pi is 6 points, so we didn't exceed that. We did great. What if I said that I wanted to subtract this other value here? Now that would have been right. I should have left it. Apologies. So what if I said, let's subtract the 2 pi thirds. Again, we would still have to have the value. So that would have been 1. So now I would have had 6 minus 2, which would have been 4 pi thirds, right? And we could have took that value. So that would have gave me approximately 4.18879. Just watch the rounding. And this would have been our other point. Okay. So, I mean, I could have subtracted the 2 pi from the pi thirds from where we started, like we did here, but it would be better not to. It'd be better to keep with this value here. Why? Because when we started at 3 pi, we went to 2 pi. Now we're going to 4 thirds pi. So we're going around the circle. It might have been over here. I have to relook again. My apologies, guys. But we're going around the unit circle, coming back up to 2 pi. So that's would be what we would want to do. Okay, if you have any questions, just reach out to me. And if you have any trouble over that section, reach out to me. Okay, so let's look at our next example. Okay, so this one here, see, it says see the equation, or excuse me, solve the equation on the interval of 0 to 2 pi, which it's going to equal 0, or it could equal 0, but it's going to approach 2 pi. It's not going to equal 2 pi. So what I'm going to do is I just want to rewrite this where it's cleaned up. The word flipped it down, took the power, put it as a regular number. So now it's written in the correct notation. So what we need to do is get x squared, or sine x squared by itself. So I'm going to add this 3/4 to both sides. So now I got sine squared x is equal to 3/4. And I'm going to take the square root of both sides so I can undo this. That means I get a plus or minus. So I have sine x is equal to plus or minus square root of 3 over square root of 4. I'm going to take the inverse of, or we can hang on just a minute on this. I'm going to take this and clean this up. Plus or minus, because this just asks for us to find the equation on the interval. So we're just looking for the interval. Square root of 4 is 2. So what I would do is say, okay, sine, we're looking for where sine, and you can go, I would go to the unit circle, unless you got it memorized, and find where sine all the way around the unit circle is square root of 3/2. Why do I say that? It's because it said plus or minus, right? So we want to get all values. And when I do that, I notice that I get pi thirds. I get 2 pi thirds. I get 4 pi thirds. And I get 5 pi thirds. And I found all the intervals within 0 to 2 pi. Okay, so I believe that might end this section. Let me double check. Yes, that ends this section.